Hey guys, welcome back to Data Products with R. In the last video, we started some sentiment analysis, and we ended for time constraints, because I want to keep these videos short, but we're going to dive right back into it. So we'll talk a little bit from our console here. Alright, so we ended where we plotted the sentiment of Darwin's four works on the origin of species, the descent of man, expression of emotion in man and animals, and the voyage of the beagle. We plotted those across the entire work, and you can see that you can get an idea of if the book's more positive, more negative, if tones change, things like that. So now let's compare the three sentiment dictionaries that we used. So there are several options for sentiment lexicons or dictionaries. You might want some more info on which is appropriate for your purpose. So here we will use all three of our dictionaries and examine how the sentiment changes across the arc of the voyage of the beagle. Let's abbreviate it there. Okay, so let's do, let's call it voyage, and that is tidy books. And then we'll say, oh my gosh, there we go, filter, and we'll say book is equal to, remember double equals, the voyage of the beagle, oops, and then we'll print out voyage. Alright, so we should get the top. What did I do here? Oh, I have to reload since I started this over. Tidy text, right? Nope. What am I missing? Oh, tidy R, not tidy text. Tidy R. Tidy book's not found. Oh. This is for some reason an old environment that I'm in. Okay, so I'm just gonna quick rerun everything from our last video. Just give me 1 second. So if you ever get that, that would, I don't know why my previous environment loaded. There we go. Okay, so we just broke apart Darwin's works into just the Voyage of the Beagle, because we're just going to look at one book in terms of the different lexicons. So let's again use integer division, which is when we did this, to define larger sections of the text that span multiple lines, and we can use the same pattern with count function and the pivot wider function that we used last time. There we go. And the mutate. So these are all things that we've used up above to find the net sentiment in each of these sections of text. Okay, so let's do, AFIN, which is one of our libraries. We'll say voyage. Oh, no, we want, that's under lowercase. Voyage, pipe down, we'll say inner join, and get sentiments, and then AFIN. Remember, so this says filter out anything that's words that are not in that dictionary file. group by index equals line number, and then we'll say we want line numbers that are 80 together, because otherwise our graph is going to be we need to bin it, right? Because there's tons of them. All right, so voyage is 208,000 lines, right? So we need to bin them into lines of 80 or groups of 80. Summarize sentiment equals sum of our value, and then mutate method equals fin, all capitals. So now let's do Bing. We'll put Bing and NRC together. Bing and NRC. So we'll put this into one function. Bind rows. Voyage. Pipe down. Mutate method equals Bing et al. That's the author of the dictionary, and so that's what they publish it. The authors, I should say, Bing being the lead author. And then we'll do voyage, pipe down, inner join, get sentiments, and then we'll say NRC. And then, how do I have two? Then we're going to pipe down because we want this within here. So don't worry about that extra parentheses yet. And then we want filter the sentiment in. So we're looking for the sentiments that are in either positive or negative. And we should have two parentheses here, and then we have our closing parenthesis, and then we're going to pipe down again. So what this is doing, so I'm going to briefly stop here. So we're saying inner join, get the sentiments from NRC. Remember, NRC had positive, negative, but also had like angry and happy or all these different ones. So we're saying filter the sentiments where all it is the positive negatives, because we can't compare happy and sad and all that stuff to the affin library, because the affin library only had positive and negative. So that's why we did that. All right, so we want to count method index equals line number. And again, we're going to divide this into chunks of 80 for not 8-80 for sentiment. And then pipe down. Then we're going to pivot wider. Names from equals sentiment. So we're getting the names from the sentiment column. Values from equals n. So that's our count. Values fill equals 0. So if there is no value, we're just going to put a 0 in there. You could pick something else if you were doing some other analysis, like a regression or something where you can't have zeros. Mutate, or you could put NAs or something. Sentiment equals positive minus negative. Okay, something's missing because it should have closed off by itself. Alright, let me check binary voyage. Okay, that's closed. Double closed. Mutate equals. Oh wait, I'm missing something. Okay. What's going on here? All right. Give me a second to troubleshoot this. Bind rows. Good. Voyage. Good. Inner join get sentiments. Oh, we're missing a whole thing here. Mutate equals All right, we're missing an inner join. So above the Bing et al, we need inner join get sentiments Bing. Then pipe down. Then we got voyage, inner join get sentiments, NRC, filter sentiments, blah, 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 positive, negative, good, close, pipe down, mutate. Oh, we're missing a mutate again. Mutate, method equals NRC, and then let's bring that over here, and that here. And then that goes here. That's the problem. All right. Please work. Fingers crossed. No. Values not found. Sum of value. It's always a plural, isn't it? At least in my case. I don't know about you guys. Hey. So we're good. We haven't chose to plot anything yet, so we just want it to run. Okay, so now we can now estimate the net sentiment, which we described as positive minus negative, in each chunk of the novel text for each lexicon, or we'll say dictionary too. Let's bind them all together and visualize with ggplot. Okay, so let's do bind rows, and we'll do fin, and then Bing. Remember we did Bing and NRC together just as an example, that you can do them together. We could have done all three together. So let's do ggplot. So if you look at Bing and NRC, we have the method, the index, negative, positive, and the sentiment. So the index would be like the line number divided by 80, right? So the index 0 would be the first 80 lines, the 2 would be the next 80 lines, etc. And then you also have the same thing for NRC. So just combine them into one data frame. So ggplot, aesthetic, index, sentiment, fill equals method. So it'll give us different colors or whatever based on method. We're going to column, show legend equals false, but if you want you can put true. Just kind of clearing it up. Best wrap by method, so each facet will be each different method. The number of columns equals 1. Scales equals free y. Okay, and no whammy. Hey, look at that. So, as you can see, so we have the sentiment, we have the index, which is just the whatever 80 lines of text there are, and then we have our AFIN library, our Bing library, and our NRC library. So different lexicons or different dictionaries are going to give you different results, right? So you have to kind of take into account what method you want to employ, and it's really important that when you compare multiple multiple books or multiple Twitter archives or multiple whatever you're comparing for sentiment, that you use the same one across each, right? Because if I use like AFIN on one book and then I use the Bing lexicon on another book, you can see that AFIN's way more positive for the same book when compared to Bing, which Bing, this is pretty neutral, right? It's kind of equal above and below. AFIN and NRC, much more comparable, right? But they're not completely comparable. So if I were to compare on the Origin of Species and the Descent of Man, in one I used AFIN and one used NRC, then those aren't good comparisons. It's not a good sound test because I used two different dictionaries. So make sure you use the same ones. And then, if you were really getting into like I want to publish a paper on sentiment analysis, then you might want to read into the AFN, the Bing, and the NRC. And there's not that one that's wrong, but there one might answer your question a little bit better, I guess is the best way to put it. Okay, so now, let's look at the counts based on each dictionary. All right, so we got get sentiments, NRC, pipe down, filter sentiment in, positive, sorry, I just want to double check I was in the right spot, negative. I already missed a couple lines of code above, right? Oh, we're missing this. All right, pipe down, count, sentiment. All right, so we run this and we see that using the NRC for the Voyage to the Beagle, that we have 3,300 positive terms and 2,300 negative terms, roughly. So now we can quick do the same thing with, what do we want to do next? So that was NRC. Let's do Bing. So we can do get sentiments, Bing. I think we can just kind of just do this. Count sentiments, sentiment. Okay, so yeah, so we had to do this for NRC because we only wanted to count the positive, negative, right? Because there's those other things, angry and sad and stuff. So for Bing, we don't have to do the filter part. So it's the same command, but we had a filter in there because we didn't want to count everything. Let's try running this real quick. So if I delete this and run it, you see we get all of them, right? So by adding that code, so positive and negative are still here, but by adding this line, I just take positive and negative. Okay, and so lastly, we need, what's the other one? AFN, right? All right, get sentiments, AFN, pipe down, count, sentiment. Let's hope this works because I, for some reason, skipped this in my code. What did I do here? Oh, I can't do it for AFN because AFN, remember, is a number score. That's why I skipped it. So we can't do counts for AFN because it's the number thing. It's not a positive or negative. We could, if we really wanted to get deep into the weeds and we didn't want to stay within a 20-minute time frame, what we could do is make all negatives, replace them with the word negative, and make all positives with the word positive and then count them, but we're not gonna do that. Okay, so moving forward. So, no, I gotta make sure I know where I'm at. Okay. So now, let's do this word counts thing here. So what we're gonna do, Bing word counts. We're gonna make a new data frame from tidy books. We're gonna pipe down, inner join, and we're going to get sentiments from Bing. We're going to pipe down, we're going to count word sentiment sort equals true, and ungroup. And then Bing word counts. Alright, so what this does, as you may have guessed, is it will give us the word. So we said, okay, look for tidy words. We're gonna get only we're gonna get the sentiments from our Bing table, and then we're going to count that number of words, and we're gonna publish the sentiment, whether it's positive or negative, and then we're gonna sort based on the number, then we're gonna ungroup and print it. So we have our word that was the most, the largest occurrence, and then we state whether it was positive or negative, which we identified from the Bing dictionary, and then we go through and we do that for all the words in our Bing identified dictionary. So this can be shown visually, and we can pipe straight into ggplot2 since we're doing tidy text, which is very convenient with using tidy text. It's almost like it's tidy or something. Dad jokes, yeah. Word counts. So Bing word counts, pipe down, group by sentiment, pipe down again, slice max, that's a new command, n equals 10. So we're going to cut them up, ungroup, it's kind of like bidding, mutate, word equals reorder, and we're going to reorder the word by the number, so they have kind of some order to it. Put them in order, and we're going to plot. Our aesthetic's going to be the n word fill equals sentiment, so it's either going to be one of two colors, and then we're going to do a column or bar plot, so geom column. Show legend equals false. You can turn it on if you'd like. And facet wrap, so we can do all of our comparisons. So by sentiment, scale equals free y. And then lastly, one more line. Our labels, x equals contribution to sentiment, and then our y is going to be, we'll just put nothing on the y. Okay, so graph. Okay, so now we have taken all of our sentiment analysis for the Bing word count, so this is only for Bing, and we made a facet where we have negative and we have positive, and then we have the score, or how many, in this case, because it's either negative or positive, so we have the count of the negative and positive for the top. What is this? 10? 1, 2, 3, 4, 5, 6, 7, 8, 9 for the top 10 words, which makes sense because we put 10 here. So essentially we just graphed this, right? Which makes it's a little easier to digest, right? So data products. We don't want to give people spreadsheets. We want to present a story visually, and so we see that great, well, and like big contributions to the positive sentiments, doubt while difficulty for negative. Okay, so let's spot an anomaly. That's not spelled right, but it will, in the data set. So, thinking about this, we talked about Jane Austen before, where miss was a word that was counted as sentiment, even though it was like Miss Austen, Miss Jane, Miss whatever. And so you may want to remove words like that from your sentiment analysis, right? So in the case of Darwin, I don't remember, I haven't read the Voyage of the SS Beagle, or of the Beagle. But for example, if we were talking about in terms of evolution, there are words that we may want to remove, like wild. So wild isn't like he's being wild, it's they live in the wild, right? And so you might want to remove dark too, because it could be referring to a phenotype. Great, I'm assuming in the terms of evolution, like we're talking about like great apes and things like that, so we're not describing great apes aren't necessarily better than other apes, it's just that they're further along on the evolutionary tree, and that's how they describe it back then. So things like that. So you might want to customize your dictionary, right? So let's do that real quick and remove a couple of these terms. So we're going to say custom stop words. And so it's always good, you'll probably have to do this depending on your analysis, right? So these dictionaries are like starting points, but when you see your results the first time, you might be like, well, that word isn't really a connotation or a sentiment word, it's more of a descriptor that just so happens to be the same word as a sentiment word. So what we're going to do, so let's remove a couple of those that we talked about. So bind rows, Tibble, words equals, let's remove wild. What was the other one I said? Dark, I guess, because that could be a phenotype word. You'd have to know the text too. Great. We'll remove like, because I'm assuming when it's talking about the same and not like I like something, it's like this one is like that one, so like saying it's equal. So I don't think that really has a positive connotation so much as it has just used in a different way. Okay, so we've done those words. And then we're gonna say lexicon equals C custom. So we're going to make sure that we note that it is our custom words, and we're going to put them into stop words. So now if we look at custom stop words, if we print that, at the top you should see oh, it's because I put words instead of word. Word equals. Okay. So you can see that we've added like, great, dark, and wild to our words that are stop words, like a, and able, and about. So we've taken those out. So now I'm just going to copy and let's see, let's see. So now if you were to run this again, copy this and paste it down here, and we're going to change let's see, where do we use stop words? Oh, we're gonna have to do it from above. It is we're not gonna, it's gonna be running too much code. So if you would take, if you reran this and you took these custom stop words and you replaced stop words, which we used way up here when we initially, let's just find. So here's, if you want to find your, I don't know what previous. It's interesting why it's Okay, so we are going to stop here. We have one more section that we are going to do in terms of this sentiment analysis before we move on to another section. We're going to do word clouds so we can visualize another way the sentiment and the words that are playing a big role in the sentiment. I hope you enjoyed the video. We're getting through it. One more tiny text mining video where we will look at word clouds. It should be shorter than this one. If you're watching YouTube, please hit like, please hit subscribe, stick with me. We'll have more great videos coming out, and I will catch you in the next one.